Sable. I am a senior solution architect with AWS. I am based in the Cleveland, Ohio area. Been with AWS for almost 3 years now. And one of the things that I've really been interested in for really my whole career, which started as a software developer, is about the move to DevOps, about agile software development, and about ways that we can, with technology, change the way we work for the better. So today I'll be talking about how to enhance your DevOps practices using AWS tools, primarily CloudWatch. So we're going to talk about DevOps, talk about application performance monitoring. I'll go through 5 foundations for success, and then we'll talk about the CloudWatch APM tools that you can use to do this in your own workloads. So what is DevOps? Anyone have a definition they want to share? There's only probably one for every person in the world, but does anyone want to hazard a guess? Or share your definition?
People that take care of the servers in the cloud.
Okay.
I'm a front-end engineer, so that's all. That's
What's that?
And expand it to infrastructure.
Yeah. Okay. Agree with both points. It's about, but it's about the tools, and it's about practices, and it's about philosophies. And so DevOps is a combination of new ways of working, new ways of approaching work, and bringing traditional disciplines of development and operations together. For a DevOps approach to be ultimately successful, I think you have to pay attention to all of these areas. So what are the philosophies behind DevOps? Removing barriers, letting people do their work without being hung up, making sure that they're productive, but also making sure that operations are running. So you don't want to take your eye off of the operations to focus only on development. We do that by encouraging communication and by giving ownership. So servers, good question. Who owns servers? Maybe everyone owns the servers in some way, right? And so we want to start to bring these philosophies into the ways that we work. DevOps practices then support this by giving you an ability to automate and streamline. You also want to focus on decoupling systems that can get large and difficult to manage, to troubleshoot. You want to focus on small and frequent software updates rather than large releases that take months and months to happen. You want to focus on small incremental updates. Another practice is managing your infrastructure as code. So before the cloud, you knew you needed servers for a project, they got ordered, someone set them up for you, and you were off and running. But now, as part of cloud development, we need to build the infrastructure as part of our code base. And ideally, we're going to shorten the amount of time that it takes to build and release software. Lastly, we want to make sure we're always logging and monitoring performance. It's going to be important, again, not to set your applications in production and forget about them, but to incorporate the monitoring and operations into your day-to-day operations. So what tools help with this on AWS? Code pipeline, code deploy, code build, and associated tools are all going to help you with CI/CD pipelines. So when it comes to writing your infrastructure as code using CloudFormation or using Terraform, code pipeline can be used to run a deployment pipeline so that while you're deploying your infrastructure, it's going through a controlled and measured process. AWS Lambda had a bad week, but it's a real key to some of these processes. As you know, you can write one-off pieces of code that they might interact with your code pipeline, they might interact with your live applications, they might be interacting with AWS APIs to give you feedback on or to kind of connect the pieces together within your software development lifecycle. CloudWatch and X-Ray, of course, are going to give you your logs, your metrics, and your traces, and allow you to get deep information about your applications. All this tooling is important. We're discussing this over lunch, but the tooling has to be there for you to get a value out of it. And I've seen many cases where the interest in metrics, logs, and traces comes up when you run into a problem and you need to resolve it. And now you're backtracking and saying, okay, how do I get this information? How do I prevent this from happening again? And what we want to do is look at incorporating this tooling into your development process from the beginning, so that you have all of these tools in place. So put all these tools together and you get a concept called application performance monitoring. I'll spare you from asking someone to define this, maybe even more nebulous. So there's a lot of tools, there's a lot of tracing, diagnostics, there's now artificial intelligence and machine learning in tools like DevOps Guru. But what is application performance monitoring really? I think it's just about monitoring the end-to-end customer experience. So monitoring infrastructure is important, but in the end, it's our users and our customers that we want to put first and foremost, and use these tools to stay in touch with what that user experience is. And that's going to be in many different levels and layers. There's not just one approach to this, right? So if we look at the layers of observability, we'll start at the top with digital experience, which is that user journey, and it's being able to track the interaction between a person and your system. The network then is everything between your resources and your users. So getting visibility into that traffic becomes necessary when you know someone on the other end, one of your customers, is experiencing issues. Where is it happening? It could be anywhere between them and AWS. The network side is about that in-between area. At the application level, you have a collection of resources. You have app servers talking to web servers, talking to database servers. You have queues and event buses, and modern cloud-based applications have many different components. The application layer is going to tie those resources together in their meaningful groups that they work within, so that if there's issues within a particular application, you then have visibility into all of the different components that make that up. And infrastructure, of course, is just our servers, our networking, our individual compute and database and so on resources that we have set up on our account. We know we can monitor individual metrics like CPU utilization and memory and network throughput. But then using all of the layers here, we're going to get a full picture of observability. So we'll come back to the tools. I'm now going to go to 5 key principles to keep in mind as you try to build out your DevOps culture. So first thing, I've talked about customer repeatedly, but focus on the customer. I'm sure everyone's been in some kind of discussion where you're debating, should we do it this way? Should we do it that way? Does it make sense to use this approach or that approach? And I think the best way to get to the end of that debate is figure out what makes sense for the customer and what is going to help to better that experience. So focus on the customer, not on pure technical goals. Leverage automation, transparency and communication, culture of accountability, and having a continuous improvement mindset. So I'll walk through a few points on these 5 areas, and then connect back to the tools and services you can use to realize this. So how do we gain alignment by focusing on the customer? It's by measuring the digital experience. So your real user monitoring, your any kind of web analytics, ways that you can understand if people are experiencing problems in any particular area, or using synthetic testing so that when you don't have users on the site and it's the middle of the day, the middle of the night, whenever you're alerted, even though you don't have real users on the site, because your synthetic testing is going through the workflows that a real user would. Feature flags and soft launches are another great way to be able to get features out there and then gauge their usefulness, survey users, watch users, and you can use feature launches to roll out the changes to a small part of your audience, measure them, and then test different features across different segments. So you might want to try a particular feature out and open it up to 10% of your audience, but then measure and make a decision on how you're going to move forward. There are tools within CloudWatch that will allow you to manage this, the feature flags and the launches, and run experiments where you can watch and see how users are working with your application. Leveraging automation. I mentioned synthetic testing. I think this is a hugely useful point. If you haven't used synthetic testing, it is a headless browser that's going out like a user would and interacting with your site. You can click buttons, you can go through menus, and if you're familiar with Selenium or Puppeteer, those are the testing frameworks that Synthetics is based off of. So you can test your user interface, you can test your REST APIs, you can just test the basic connectivity with a heartbeat to monitor the site. Simplest use cases, you can run a heartbeat check once an hour, and it's just gonna say, yes, I got a response from this URL, so your site is still up. We should share that with our biker from this morning, right? That would tell you that your website is down before you log in to find out that it's down, right? Internet performance is a huge area of focus for Amazon because of the e-commerce network and the need really to be able to reach customers anywhere that they are. Because of the vast amount of effort Amazon has gone into measuring the internet performance globally, you now have a tool called Internet Monitor in CloudWatch that allows you to see the interaction between your system and ISPs. It will highlight where you're running into problems in specific segments of the internet. If you were running some type of mission critical application that needed to have 5 nines of uptime, and you had redundant internet providers, and you wanted to be able to detect when one of your internet providers was having degraded service and be able to switch over on the fly, this is what Internet Monitor provides you. Definitely for larger scale, global, mission critical types of applications, but it's a huge benefit because the amount of effort and money it took for Amazon to build is really not feasible for most companies, unless the service was just launched at reInvent last year. You can collect your fine-grained metrics and logs for your AWS services. Many of them are naturally emitting metrics to CloudWatch. You also have the ability to publish your own metrics. And if you're not doing this already, it's always a good idea to route your server logs into CloudWatch logs so that you can then build filters on them. You can alert off of things like a specific error message on your Apache web server. You now have that ability to spot that centrally and alert. The goal with all of the automation is to be able to move faster. And I think that's one of the keys of DevOps. It's the cloud and the value you can create is really diminished or eliminated if you move slowly. The benefit is to be able to use these tools to identify issues quickly, reduce your mean time to identify them and to resolve them. So transparency and communication. I think people think about dashboards or status reports, meetings you go to and talk about what's going on. And I think the number one thing when it comes to communication is actually alarming. It's not common for people to sit around all day, just looking at your dashboards, right? You're not waiting to see something come up, but you need to use that as a way to investigate more fully when you receive an alarm, an alert that one of your thresholds is breached. So in addition to giving this transparency, it's important to think about what your thresholds are and not wait for something to stop working to realize, but really focus on stress testing and performance testing your application as you're building it, set those thresholds, build your alarming in, and then you have the central source of operational data. You can also route the incidents that you identify into Systems Manager Ops Center. We do integrations through EventBridge to many other systems. You can feed into your own ITSM system like a Jira or ServiceNow. So part of that transparency is if you're used to using tools outside of AWS, then that's fine. Take the data and the information you have, get it into the tools that you need. And if you get it into your ITSM system, you can follow that through as a ticket. It will help to get this type of transparency and quick response like you would expect with any type of ticket that gets put in. This is just going to be automated. Accountability is a big part of this DevOps concept, because the idea that I built it and my job is to build it and I don't support it or operate it it's not good for the customer, right? It's not best for the end result. And my experience as a developer is if you're building something, you want to own it, right? You should take pride in it. And part of writing software is that it has to work, right? So even as a software developer and software development manager, I like to put the onus for test case development and execution on the developers. People are probably used to unit testing and doing things like that within your development environment, but think about synthetic testing, the ability to say, okay, I want you to write a web-based test that clicks through the functionality, demonstrates that it works. We're gonna include that test case in our code base. It's going to go through our CI/CD process. You can run those test cases automatically as you're building, track and publish the results, and then give that result back to the people, the teams that built it. So you want to group the results, the canaries, in a way that matches your organization. So group these by teams, by business function, by the customer workflow, whatever way you align as an organization, attach those teams to the results that they're generating, publish them. You can make it more into, I think it's important to make it a positive thing, right? We want to achieve 100% quality. It's not about the negative aspect of something failing. It's actually the point of this is that you want things to fail in development, not in production, right? So last point of this is continuous improvement means you're constantly looking for ways to improve. You have a variety of metrics and the ability to do tracing to help you identify bottlenecks and where your performance has degraded. We have real user monitoring and A/B testing that I've talked about. And so I like to look at continuous improvement by having a separate backlog, essentially, of your improvement initiatives, measure them by customer impact, and then seek to constantly include those in your releases 1, 2, 3. I think the idea of continuous improvement means it could be as simple as every sprint you do, pick one improvement and if you, as I'm sure you know, you let these problems build up, it becomes much, much tougher to resolve them. Leveraging these tools from the beginning and focusing on that constant improvement will lead to, I think, better long-term results. So the tools, back to our stack that aligns here. On the digital experience side, you have synthetics, CloudWatch, real user monitoring, and evidently. The network side is Internet Monitor. On the application side, you have X-Ray, CloudWatch ServiceLens. The insights features as well are kind of pre-built dashboards that encompass the concepts like container versus Lambda that you see here. And then our low-level infrastructure monitoring. The foundation of all this is our logs, metrics, and then the alarms and dashboards that we build off of this. So there's a lot of tools here, and I don't know how familiar everyone is with them, so I'm just going to go through a few semi-live demos here. Synthetics canaries are going to be listed, and you can group those. As you can see here, you're going to see performance over time. You can then drill into the results. You can see screenshots, you can see your logs and your traces all attached. And you can, again, alarm off a failure. So what this can do is alert me that something that I did might have released has impacted the application, or there could be some outside impact. Whatever the case is, we know that some user interaction or what a user would be doing is not working. So this is synthetics. Real user monitoring looks very similar to web analytics packages you have probably used. This is great to narrow down what are your actual users experiencing versus a synthetic test, which is all really originating from the same place on AWS. The user monitoring is coming directly from your users. It's also incorporating your client, like your browser. So is this a Chrome, Safari, Firefox? And you can then see a lot of detail on each request and identify performance problems that may be specific to the application, or they could be specific to the location or the browser of your user at the time. This is Internet Monitor. You can see all the different networks that are being monitored in this case. Internet Monitor will look at your application and the traffic. It'll understand where your users are come from, and then it will monitor the networks accordingly. You do determine how fine-grained you want this to be. The higher level checks you run are going to be more cost-effective. You can monitor this down all the way to the city level, like 10,000 plus points of data, but then the cost will adjust accordingly. So you really need to figure out if this is meaningful to you, at what level you need to be able to monitor at. This is going to allow you to do your feature launches and your experiments. So you can see in this case, there was a experiment to do an upsell, and there was a new message added in a shopping cart. And this is tracking to see how many people clicked on this button and accepted the upsell, so that we can measure the success of a particular offer or not. So we see here the events over time, the variation. Then you can set the split of traffic, who you want to see what version. And then if you decide you want to go ahead and launch, you can do that with one click, and then the feature is live for everyone. ServiceLens map is my high-level picture of my components and their interaction. So in a large distributed application, you have your web servers, your database servers, you have ECS or EKS clusters, you might have SQS queues. There are the supported services here. API Gateway is another one. We'll build this map automatically for you. It's going to help to identify bottlenecks in the process. You can see the red highlight on this gear in the middle, and that's telling me that an alarm is going off on that component that I have set, and I can then drill in. This is excellent for looking at the user journey as a whole, because this is showing me the interaction between my different components and if there's a failure anywhere within that. So if you want to learn more and experiment, the One Observability Workshop is everything that you can do with AWS Observability in one place. There is a cloud native section And I've today talked about all the AWS cloud native services. You also have the open source observability world, where you have tools like open source tools like Prometheus, Grafana, and others that are more like you might use them already, and that's an easy path to build observability. And so all the same concepts apply, different tool sets on the AWS native and open source side. So highly recommend this workshop. We also have an observability best practices site that was just published late last year. It's on GitHub, and it is a community-based effort within AWS. I wrote a couple chapters, and I think a few dozen people have contributed to that. That's a comprehensive guide, and it's not AWS specific. It goes through first just basic monitoring and observability independent of any application or cloud system. The Skill Builder, if you haven't used it, is our free online training platform. And there are some, there's a good AWS observability series in there. And that is that. Thanks everyone for your time. Let me know if you have any questions. I'm happy to answer. Yeah.
I mean, a question on the container instance on the application performance monitoring.
Yes.
So do we need to just enable that feature, or do we need to deploy it? I have things running on EKS. We're using that and it's for performance monitoring, probably from the traffic or the container address.
Yeah.
The typical API solutions. But how does it compare with that solution? That is one thing.
Yeah.
And second thing is they use the agents to monitor the performance. So how do they have the themes and other specific track. So how does it work with container? Do we need to install anything or just enable?
So the container insights just needs to be enabled, and then that will feed data in. With Kubernetes, there's two approaches. You need to get you'll need to get an agent on there, like your CloudWatch agent or your X-Ray. That you can do either as a standalone or a sidecar approach, or you can build it in. I think the recommended approach for that is a sidecar approach. So you just have a pod that's running the tool, and then you can connect with that and interact with that. I know there's, as part of the setup for EKS and monitoring, you'll find online, there's a guide to how to set it up as a sidecar. Yeah. Okay, anyone else have any other questions? All right, thanks everyone.